What's up, everyone? Welcome to today's math class. We are going to continue our study of the area of regular polygons. Today we have two more regular polygons that we need to talk about. So go ahead, grab yourself a pencil, grab a calculator, get out your formula sheet, and let's get right to it. So a quick review from yesterday. What is area? Remember, area was the amount of space inside of a two-dimensional object. And how was it measured? We always measured area in square units. So anytime you were calculating area of a polygon, you were essentially figuring out how many square units will fit inside of that two-dimensional object. The first polygon we're talking about today is the area of a triangle. So area of a triangle, we have a picture of our triangle here, and our formula A equals 1/2 BH. This matches our formula sheet. The triangle is the very first object on our formula sheet. And here we have our formula A equals 1/2 BH. B standing for the base of the triangle, which will be one of the three sides. And then H is the height of the triangle, which is a perpendicular or a right angle measure from the base to the opposite vertex of that triangle. All right, so we have our first example on the screen. We have a triangle we are being asked to calculate the area of. So please grab your sheet of paper, work along with me. First off, we are calculating area, and I know that this figure is a triangle, so from your formula sheet, you should be calculating area of a triangle by copying down the formula first. A equals 1/2 BH. So I'm copying down my formula. Area equals 1/2 BH. Well, I don't know the area of this triangle, so I'm going to keep my variable A. We're going to bring down our 1/2. 1/2 is touching B, which means multiplication. We're going to multiply 1/2 times the base. The base of this triangle's measure is 10. And then B is touching H, means more multiplication, and we're going to plug in the H. The height of this triangle is a measure of 4 centimeters. We're ready to calculate. We can do all this multiplication at once. 1/2 times 10 times 4. Grab your calculator if you need it. 1/2 times 10 times 4 works out to 20. We are measuring in centimeters, and because this is area, that would be 20 square centimeters. Okay, on the screen I have another triangle for you. I want you to try to calculate the area of this triangle all your own. So pause the video, copy down your formula, and perform your calculation. When you're ready to check your work, hit play again to see how you did. Okay, let's check your work, starting with our formula. Area of a triangle is calculated 1/2 times the base times the height. 1/2 times the base in this case is 6 kilometers times the height is 2 kilometers. We're now going to perform our calculation. 1/2 times 6 times 2 gives us 6 square kilometers. Okay, final regular polygon of 6th grade. We need to be able to calculate the area of a trapezoid. So a trapezoid is a quadrilateral, meaning it has 4 sides. And to be a trapezoid, you need opposite sides that are parallel to each other. In this case, the way this trapezoid is oriented, the parallel sides are the top and the bottom. Formula: A equals 1/2 H times the quantity of B1 plus B2. You can grab this formula straight from your formula sheet. The trapezoid is the top of the right-hand column. Here's your trapezoid. Area formula, just like we mentioned, 1/2 times H times the quantity of B1 plus B2. Now, let's actually talk about this formula, because this is by far the most complex geometric formula we have for regular polygons in 6th grade. A, obviously, is the area of the trapezoid. Let's hop in and let's talk about B1 and B2 for a second. B1 and B2. Just like the triangle, the B's stand for base. And the 1 and the 2, every trapezoid has 2 bases. So the first base is always represented by B1. The second base is always represented by B2. And if you look at our diagram, where do you notice that the bases are located? The bases of the trapezoid are the two sides that are parallel to each other. In this case, the top and the bottom. Now I could have this same trapezoid and it could be rotated 90 degrees, and the bases would still be the two parallel sides. Just in this orientation, it would be the left side and the right side. So be careful. Don't get in the habit of just picking the top and the bottom. You're looking for the two sides of the trapezoid that are parallel. One of those sides will be base 1. The other parallel side will be base 2. And it actually doesn't matter which side is base 1 and which side is base 2, just as long as you account for both. And then our final variable, h, just like the triangle, is the height. And don't think of the height as how tall a trapezoid is, because again, the trapezoid could be rotated 90 degrees sideways. The height instead, think of the height as the distance between the parallel sides. So how far apart are the parallel sides in your trapezoid? That measure will always be your height. Okay, let's go ahead and try an example together. So we have a trapezoid on our screen. We are being asked to calculate the area of it. So just like every polygon we've worked with so far, step 1, copy down your formula. From your formula sheet, if you need it, area of a trapezoid, 1/2 times h times the quantity of b1 plus b2. 1/2 times the height times the quantity of b1 plus b2. Now, because there are so many variables in this formula, I like to declare my variables on the side. So starting with, let's do our bases first. Remember, our bases, base 1 and base 2, those are the two sides of the trapezoid that are parallel to each other. And in this case, it's the top and the bottom. I'm going to say that base 1 has a measure of 3 inches and base 2 has a measure of 5 inches. And I'll also need a height. The height is how far apart those parallel sides are. In this case, we have a measure of 2 inches. So now I can just substitute these values back into my formula. 1/2 times, in place of the h, we're putting 2. H is touching the parentheses, that means more multiplication. And in those parentheses, we have base 1, which we said was 3, plus base 2, we said was 5. Now we have multiple operations occurring in our formula. Please follow your order of operations, starting with your grouping symbols. 3 plus 5 is 8. Rewriting the rest of my formula, area equals 1/2 times 2 times 8. I can perform all that multiplication at once. 1/2 times 2 times 8 gives me an answer of 8. Because we are measuring area and the original dimensions were inches, these would be 8 square inches. All right, we have one last trapezoid on the screen for you to calculate the area of on all your own. So take a moment, pause the video, copy down your formula, calculate the area of this trapezoid. Be sure to include proper units. When you've completed your work, begin playing the video again to check to see how you did. Okay, let's go ahead and check your work. Starting with our formula, area of a trapezoid is 1/2 h times the quantity of b1 plus b2. Looking for b1, b2, and an h in this trapezoid. Base 1 has a measure of 10, base 2 a measure of 15, and the height, the distance between those bases, is 4 meters. Now let's substitute our values into our formula. We get area equals 1/2 times a height of 4 times the quantity base 1 we're replacing with 10 plus base 2 we're plugging in a 15. Order of operations tells me to simplify my grouping symbols first. 10 plus 15 is 25. Area equals 1/2 times 4 times 25. Final step, we can do all that multiplication. We should get a final area of 50 square meters. Boys and girls, go ahead and complete the independent practice assignment on regular polygons today. Use your calculator and formula sheet if you need to. Take a picture of your final work and upload that file for submission. I'll talk to you guys next time.